Hello everyone, this side Preet Kamal. I'm a lecturer at Mahesh Polytechnic College, Jalandhar. Today I'm here to discuss with you about the subject of computer networks. But before starting with the subject details, I would like to share an important information that is about Mission Fateh, a campaign run by Government of Punjab. It says that we should wash our hands, we should use sanitizer, use mask while we go out of our house and maintain the social distancing rules so that we could come out of the pandemic situation of COVID-19 as soon as possible. Okay, so let's quickly move on to the today's topic of computer networks. Today I will discuss about the IP addressing, but before that, as we have discussed in the last lecture about the physical and the logical address, so in that regard, I've just missed one point, and today I'm going to discuss that with you, and that is the mapping of the IP address into a MAC address. As I have already discussed that. Whenever we talk about the mapping, then it means that the IP address and MAC address could be used simultaneously. Like when we know about the IP address, then we could find out the MAC and vice versa also. And I have already told you that there is a table that is being made in the server or in the network so that we could know about the physical and logical address of one particular system or all the systems that are in between a network, right? So if the table has been made such that it has been created or stored in one machine, and it associates the IP address and MAC address, and we mention them in a manual format, then we could say it is called as a static mapping, and we could not change that IP address or MAC address if, say, in some case we have to shift one PC from say one lab to another or one LAN network to another network. So if it is a manual thing, then we have to change it manually. That is called static mapping, and it will become very difficult sometimes if two or three pieces have been changed from one network to another, or they have been replaced because of the problem, because of some kind of a problem, or if they are not working, then it becomes very difficult in case of the static mapping. No doubt the table has been written, but we have to change it, we have to update it regularly manually, and that becomes sometimes very difficult process. And if we do not change it, or if we forget to change it, then we will not be able to find the perfect matching of the IP and the MAC addresses, right? So that is why we use the dynamic mapping, in which there is a technique, there is a protocol that is being utilized, and for updation of the static that table regularly. So whenever there is any change, then it automatically updates that particular table that is stored in the machine. And the protocols that are used in between are address resolution protocol, as I have already discussed in the last lecture, and the second one is the reverse address resolution protocol. So one is for mapping IP into MAC, and another one is for mapping the MAC into IP address. So in a reverse process, both of them are utilized. So here I would tell you that the packet consists of IP and MAC. So if we need to convert IP into a map, or we are having IP address and we need to find the MAC address, then ARP is used, and the reverse process, the RARP is being utilized, right? So next one is the IP addressing. We are having a vast IP addressing module, right? We know that it is the logical addressing. MAC addressing, we are not in MAC addressing, because that is designed or that has been fixed by the manufacturer itself. So that is why we need to know that how IP addresses work, or how IP addressing works. So it is basically called as a class full addressing or classless addressing sometimes, but we generally use a class full addressing. So if we talk about the IP addressing, it is having 5 types: class A to class E, and 32-bit IP address. The IP address will be 32-bit, as we have already discussed, that is IP addresses having the address in 4 octates. 4 octates means 4 into 8 bits, so that means 32 bits, right? The IP address will be of 32 bits, and there are 5 subclasses, that is from class A to class E, and all of these classes have a valid range of IP addresses in which it can be worked or it can be utilized. But when we talk about class D and class E, then they are specifically reserved for some multicast or some experimental purposes respectively. So in order, so the order of the bits in the first octet determine the classes of the IP addresses. Whenever we are having a 32-bit IP address, the first first of the bits, some of the first bits combinedly, they will get us to know, they will seeing those bits, we could recognize that in which class of address that IP address is lying. Now I will tell you how in the next slide. Right, first of all I would like to tell you that IPv4 address, when we talk about one address, one IPv4 address, either of the categories it is lying, but it will be having two parts. The IPv4 address is divided into two parts. The first part is called the net ID or the network ID. The second part is called the host ID, right? So this you have to remember, that IP address is having two parts. It is divided into two parts. When we talk about the subclasses or the types, then we could say it is class A to class E. But when we talk about the parts, that how many parts IP address is containing, that how is it divided, then we could say it is divided into two parts, that is network ID and host ID. So the class of IP address is basically used to determine the bits used for the network ID and host ID, and the number of total networks and hosts that are possible in that particular class. When we talk about the classes, it will tell us that how many bits, for example, say in class A, how many bits are needed for network ID and how many bits are needed for host ID. So the classes will tell us that how it is divided, right? And along with that, how much is the number of host ID. So it will tell us that how many number of hosts, how many number of PCs are possible to be connected into that particular class of the address, right? So each ISP or the network administrator assigns IP address to each device that is connected in the network. How many PCs, how many number of PCs are connected in the network, everyone will be having its own IP address, and that is being assigned by the network administrator. So if we will talk about how this IP address looks, as I've already told you, it is having 4 octates. How this IP address looks, it is something like that. This, if we will talk about the decimal notation, it is called the decimal notation, and it is written in decimals. It is not written in hexadecimals, as the MAC address was written in hexadecimal format using colons in between, but the IP address is used it is written in the decimal format using dot in it to distinguish between the 8 bits, right? So for example, say first is 192, then is 0.168, 0.100, 0.1. This is called the total IP address, that is represented named as 32 bits. So each octet is having 8 bits in it, right? So 4 octates, 32 bits, 8 bits in each octet, and this is the way, this is the decimal notation. Not it is necessary that it will always start from 192. It will start from 0, from 0.0.0.02 up to 255.255.255.255. This is the total range of the IPv4 version IP addresses. All the addresses are utilized in between. I will tell you how and where. So here, as I was telling you, that in the class A, B, C and D and E, we are having network ID and host ID. In class A, the byte 1, the first octet, the first 8 bits, they are utilized as net ID, and the last 24 bits are utilized as host ID. If we'll talk about class B, then first 16 bits are used as net ID, and the last 16 bits are used as host ID. Host means the number of PCs. It tells, basically it tells us the range of the PCs, the number of PCs that could be connected in that particular network. If we will talk about class A, then how many PCs could be connected? Class B, how many PCs? Class C, how many PCs? It will tell you that. For example, here the host ID is, say, 24 bits wider, right? So the number of hosts, the number of PCs that could be connected in this class A are 2 raised to the power 24. In case of class B, it will be 2 raised to the power 16. In case of class C, the net ID is 24 bits wide, and the host ID is 8 bits wide. So the number of hosts, number of PCs that could be connected in with one single network ID are raised to the power 8, that is 256. Class D and class E, as I've already told you, they are reserved. It is reserved for the future purpose, and class D is used for the multicast addressing, right? So here the bit patterns that you have to remember, the bit pattern in case of, that is why I have made these two photographs together. So that you could come to know that how these bits are being divided, right? So here the bit pattern of the first byte, that means the net ID, the first byte in each and every class, how these bits are being written. The first bit in this class A of the first byte, the first bit of this first byte will be 0 in case of class A. It will be 10 in case of class B. Rest of the net ID will be whatever, but the first 2 bits will be 10, as they are reserved, as they are by default set by the network administrator like this only. That you have to remember it, that these are the bits and they will define the classes of the addresses. So when you will see that the first bit is starting from 0, then you will say that it is a class A address. If you will see the first 2 bits are 10, then you would say that it is class B type of address. To distinguish between all the addresses, all the classes, so that we could identify with the help of the number of bits that are being provided to the net ID, right? The byte 1, right? If class C 110, if you will see in the net ID is starting from 110, then you will say that it is class C type of address. If it is 110, then it is class D type of address. And if it is 4 times 1 and then 0, then it is class E type of address. So it is a bit pattern that is by default set, so that we could know, we could find out that in which class or of which class of IP address we are talking about. Okay, one more thing, that is if you will not be able to see it in the format of this binary format, if you are unable to learn or unable to understand or unable to see it in this format, so I will tell you how in the decimal range you could recognize that which decibel range is for which class. For class A, the net ID ranges from 1 to 127. Whenever you will see any address starting from 1.0.0.1 2 up to 126.255.255.254 or 1 to 127 or 1 to 126 point this thing, then you will say this is a class A type of address. If it will be ranging from 128.0.0.1 to 191.255.255.255, it is written wrong here, up to this 128.0.0.1 to 191.255.255.255, then it will be a class B type of address. If it will be ranging from 192.0.0.1 to 223.255.255.255, then it will be under class C. From 224 to 239, it will be class D. From 240 to 255, it will be class E. So you have to remember these first byte decimal ranges or the dotted decimal assignment range that is shown here, so that you could recognize after just seeing. Say if I will say your address is 172.0.1.3, something like this, right? So what you will say, it is lying under the class B type of addressing, right? So by seeing these decimal ranges, you could recognize that which kind of address it is. So it is also here the local host address, the bits that I have already discussed. It is being written here in some in detailed formats. That is why I have used this photograph here. That class A is having 0, it is having 10, it is having 110, it is having 1110. So class A ranges from 0 to 1 to 127, right? Then it is from 128 to 191, then it is from 192 to 223, and then class D ranges from 224 to 239, and then from 240 to 255, right? So this was about the classes of addresses. One more important thing here about the classes is that you have to remember that how much net ID, how much bytes the net ID is taking, it is lying under that kind of category, right? Say class A. So if there is a 1 byte net ID, it will be of class A. If there is 2 byte net ID, it is class B. If it is 3 bytes net ID, it will be class C, and rest of the all you can remember, it is multi-class net is reserved. And one important thing here is that as I have told you, that host ID means that how many number of PCs you can connect to that particular network. So from all these, can you tell me that which of the class of addresses will be most popular? I hope you will say class A. I will tell you it is not. It is not even class B. It is the class C that is the most popular. And why? The reason behind this is, when we talk about one network, for example, if there are the hosts 2 raised to the power 24, so if we will calculate 2 raised to the power 24, I think it will be in crores, right? So, or say millions or billions, right? So is it practically possible that our only one organization which is taking this network ID in one particular organization, will it be having millions of pieces to work on? No, they will not be having. So that is why this class A type of addresses are not utilized practically. If we'll talk about class B, it will be 2 raised to the power 16. That is also in lakhs. So it is not practically possible for any organization to have such a huge number of PCs in one organization. It will be uh, in a particular country, you can say. There will be lakhs or millions or billions of PCs in one country, but not in one organization. And whoever will take this network ID, that will be one particular organization. So that is why if an organization is having say 10,000 PCs even, then also from 1 lakh only 10,000 host IDs are being utilized, and rest of the all are wasted. So that is why this class B network also is of no use. So now that is why the class C type of address has become so much popular, because it is having a host ID of 8 bits, and 2 raised to power 8 means 256 PCs or 255 PCs. If and that is a practical kind of an amount or these number of PCs could be there in one organization, and if we are having say more, then we could purchase more class C net IDs, more network IDs we can have. We can have 4, we can have 5, and we could utilize all of them. So if we will use say 4 class C type of network IDs, then we will be having 1,000 of PCs, and they are more than enough for one organization to work upon. So that is why the class C network has become so much popular that these addresses are even used till the version IPv4 was there, right? And then the last one is the special type of IP addresses that we are having. As we have seen while seeing this, while explaining this class type of addresses, we have seen here that it is saying 1 to 127, and here it is written, the range is written from 126 from 1 to 126.255.255.255. Where is 127 range of address? So these are basically used here. These are the special IP addresses. So 0, all zeros is called as this particular host. When talking about, when sending some data to particular host, to one particular host that is generating that data, then all zeros are being utilized. This is a special IP address, not used for any particular, any PC in the network. They are specified for some specific purposes. If the net IDs, if in the net ID all zeros are there and there is a host ID, then that is called a host on this network, the host on this particular network on which it is given. If there will be all ones means the net ID, the host ID combining all the 32 bits, all are ones, then that will be called as the data is to be broadcasted on the local network. And if there will be a network ID, a separate network ID, any network ID, but the host ID is having all ones, then it is for broadcasting on a distant network, on a particular network of which this network ID is given. Then we will use this type of special IP address. And for 127.0.0.02 up to 127.255.255.255, it is called as the loop back address. Why it is called as a loop back address is because it is to check whether our whole addressing system, whether our whole network is working properly or not, to check the loop back. Or in detail, I would say that the loop back, these special IP addresses, loop back interfaces means all the addresses from the 127 range, they are reserved for the loop back interfaces. So most of the systems uses these loop back addresses, and loop back interfaces is associated with the name of local host, so that it could check the functioning of the network, that how it is working, that whether it is working properly or not. Then when we talk about the IP address of a network, then we can say that host number is set to all zeros. The host number is set to all 0. That is called the IP address of that particular network, right? Then that means here you can say the 128.143.0.0. So host number is 0, so IP address of that particular network we are talking about. When we talk about the broadcast address, then the host number is all ones. The host number, host ID is all ones. All ones means 255.255. So this is the example given here. So this broadcast goes to all the PCs, all the hosts, all the systems in that particular network. So that is called the broadcast address, and it is often ignored due to the security concerns. Then there are some test or experimental addresses. So these are some certain special range of addresses. They are reserved for the experimental uses. So packets should get dropped if they contained this destination address. So if you will send the data from these in these ranges, then the packets should get dropped off. So your packet will not go to the destination if the destination address will in these ranges, because this is called basically the test or the experimental addresses. Then a default gateway is being used, and that has the host number set to 1. For example, say 192.0.1.1. So this is a conventional address, a default gateway that has been utilized, and this is called as a special type of IP address, right? So this is all about the IP addresses, the special IP addresses, that how our IP addresses work, what kind of classes they are having, and this was all about today's lecture. So I hope you all are clear with all the things that I have discussed with you today in this lecture. So I would say you now that like my video, so that I could come to know that how many of you have seen it entirely. Then you must comment anything related to the topic, related to the contents, related to the doubts, or related to anything good that you have find out in this particular video. And till then, we'll meet in the next lecture. Thank you.